Yes, friends, good morning. And now we'll continue the examples. So, before going to these examples, you should first go to the previous examples. So, please remember, before understanding these examples, you should know what are the applications, what are summary of the Fourier series, Fourier transformation you have gone through. Before this lecture, you have to go to the previous lecture. It's a very important lecture we have discussed, very simple examples we have done. So next we'll continue towards the next examples we are going to see as students. So you can see the last class we have done the very easy examples we have done. Now further we'll continue this examples. Yes. So you can write down the next example, students. Now you can see in the previous class we have gone through the examples where interval they have given pi to minus pi. So here the interval will change, functions will change, students. Formula remains as it is. So obtain the Fourier series and just write this as fs of the function. I'm going to take this as f of x is equal to pi. So you can see the function is changed, that is pi minus x upon 2. In the interval now they have given 0 to 2 pi. Hence deduce that 2 1 1 upon 3 plus 1 upon 5 minus 1 upon 7. Okay, this must be equal to pi by 4. It's okay, students. So we'll go through the same again once again. We'll see, first write the formula. Before writing the formula, first you should know what is the interval given here, students. I'm going to take here the interval. You can see it is 2L. Suppose this is equal to length. I have to find first. You can see the length here they have given from 0 to 2 pi. So 0 plus 2 pi will be 2 pi only. So length will be, that implies length I have to take here as pi. So L is equal to pi. So you know the formula, that is f of x is equal to a naught upon 2 plus summation n cos n pi x upon L plus summation n bn sin n pi x upon L. So L is pi. So pi will get cancelled. Therefore, I am going to write this function as f of x is equal to a naught upon 2 plus summation n1 to infinity. No, don't worry. n1 to infinity. Yes, it is an cos n pi x upon pi will get cancelled. That was I was saying. So nx you will get here plus summation n1 to infinity bn sin nx. So this is what we have the Fourier series formula. So please remember this and practice again and again, students. Now already I told you it is very simple example. Just calculate a naught, an and bn. Substitute the values in this. You will get the Fourier series answer. Now we'll just find a naught first. So a naught is equal to 1 upon pi. Integration, you are going to take the interval 0 to 2 pi they have given. So I'm going to take here 0 to 2 pi f of x dx. So you are very much familiar and practice this integration. So you can take this as equal to a naught is equal to 1 upon pi. So f of x you can see in the question they have given here, students, that is pi minus x upon 2. So just substitute here 0 to 2 pi. This is pi minus x upon 2 and this is dx. So now you can see here, students, what is the constant here. Constant, I'm going to take this 2 outside. So this integration you can write like this: 1 upon pi, 2 pi. I will take 2 outside. Integration pi minus x will be there. As pi is constant, so I will take this as pi x. Integration constant is always x. Minus integration of x. Yes, integration of x is x square upon 2. So please remember this: 0 to 2 pi. Okay, first I will substitute 2 pi. 0, if you substitute, it is 0 only. So don't worry. This is equal to 1 upon 2 pi as it is. So x is 2 pi. So this is pi, 2 pi minus 2 pi square upon 2, and remaining it is 0. Don't worry. Further simplify, this is 1 upon 2 pi. This is 2 pi square minus 4 pi square upon 2. So if you simplify, students, you can see if you take the LCM, you will get the value like this. This is equal to 1 upon 2 pi. This is 4 pi square minus 4 pi square upon 2. So which is equal to 0. So A naught you have calculated, it is 0, students. Okay. Similarly, you have to calculate for Bn. Is it clear? So Bn is equal to, you can calculate this, students. First we will find An, sorry. After that you can find Bn. So I'll go with An is equal to, yes, write down the formula, students, here again. Length we have taken, that is C, we have taken it as pi. So 1 upon pi. Integration, you can see the limit they have given, 0 to 2 pi. Okay, f of x, and then cos n pi x upon L. So L we have taken it as pi, therefore I am going to write this as cos nx, and this is dx. So further if you simplify this is equal to 1 upon pi, integration 0 to 2 pi. Substitute the value of f of x, that is function they have given here, students, pi minus x upon 2. Remaining terms write as it is. Okay, this is equal to, continue this, students. Now 2 is constant, I will remove it outside. So we am going to get this as 1 upon 2 pi. Okay, here again, same way, again you are going to take integration u into v. So I think you are familiar now, you have practiced integration of u into v. So I will show you what is integration of u into v. Here, integration uv is equal to Bernoulli's rule. Keep u as it is. Integrate this v1 minus u dash v2 plus u double dash v3. They can take this as u is equal to pi minus x upon 2. Okay, when you go for u dash, yes, you can see this is, I can write like this, instead of pi minus x upon 2, I will write pi upon 2 minus x upon 2. I have just taken separately 2 here and there because pi upon 2 minus x upon 2 will be easy. Integration, differentiation of pi upon 2 will be 0, and minus this is, in differentiation of x is 1. So this is how you have to simplify. Okay, same way if you take the value for v. So okay, we can take the, if we say further simplify, you are going to get this is equal to minus 1 upon 2 u dash, and u double dash will be 0. Similarly, we will go for v. I have taken v is equal to cos nx. Okay, is it clear? Cos nx. So when you go for v1, that is integration of cos nx will be, yes, it is sin nx upon n. Then go for v2. Means again integration of this 1 upon n is constant, so write 1 upon n outside. Integration of sin nx will give you minus cos nx upon n. So this is equal to, minus I will keep outside, cos nx, n into n will become n square. No need of calculating v3. Okay. So now we'll substitute the values here. Okay, I will take here. So this is u and this is v. So this is u and this is v. Substitute one by one. Keep u as it is. That is pi minus x upon 2 remains as it is. v1, that is integration of cos nx, will give you, it is sin nx upon n. Then minus, so you can see already we have calculated the value, that is, so 2 we have taken, wait, so 2 is here, taken it, I have taken u is equal to pi minus x upon 2. Okay, this is again minus, we can see u dash is nothing but minus 1 upon 2. Okay, then v2, that is, substitute here, minus cos nx upon n square. If you go for u double dash, it is 0, so no need of calculating. So this is from 0 to 2 pi. So here you can see what all constant terms I can take outside, students. 2 is constant in both these equations, so 2 I will take outside. N is constant, that n also I will take outside. But please remember, yes, please remember the formula, that is sine 2n pi is equal to 0, which is nothing but again sine 0 is also 0. So please remember this formula, means if you substitute 2 pi is also 0, if you substitute 0 is also 0. So what is remaining here, students? I will write here directly, that is 1 upon pi is remaining. Here minus into minus plus, plus into minus will become minus, so minus cos nx upon 2 n square is remaining, again from 0 to 2 pi. Now whatever constant terms are there I will take outside, so I will get here minus 1 upon 2 pi n square I have taken outside. What is remaining is cos nx is remaining from 0 to 2 pi as it is. Now substitute here, friends. So I'm going to get this is equal to minus 1 upon 2 pi n square. First substitute 2 pi. So I'm going to get this as cos n 2 pi, subtract minus cos 0, this is, yes. So please remember here once again, it is cos 2 n pi will be equal to this, you put it in calculator, you will get the answer, or you put it in as radian. This is equal to again cos 0, so 1 1. So if we substitute 1 1, so we can see minus 1 upon 2 pi n square, here this is 1 minus 1, which is 0. So therefore an you have calculated the value, that is 0. Similarly you are going to calculate for bn. Okay, no problem, we'll calculate for bn. First you please write for the formula for bn. So bn is equal to, it is 1 upon pi integration from 0 to 2 pi f of x, and then we are going to get this as sine nx dx, sine nx dx. Okay, now we'll calculate the value. Yes, it is bn is equal to 1 upon pi. Substitute the value of f of x, students. What is f of x? Yes, it is pi minus x upon 2, and this is as it is, keep this as it is, nx. Okay, now take 2 outside. I'm going to get this as 1 upon 2 pi integration from 0 to 2 pi. What is remaining here? It is pi minus x is remaining, and here you are going to get this as sine nx dx. So I will take this as u and this is v. So integration of u into v, product of two functions runs, it is u v1 minus u dash v2 plus u double dash v3 and so on. So please take u is equal to pi minus x and v is equal to, I am going to take this as sine nx. So u dash will be what, friends? Minus 1, and u double dash will be 0. Similarly, if you take v1, we are practice now. Please remember integration of sine nx. You are going to get this as minus cos nx upon n, and v2. If you just simplify, you can calculate here directly. Substitute the values. It is integration of sine nx will be cos nx will be sin nx upon n, means minus sin nx. You are going to get n into n will be n square. For all this, simply substitute in this value. So this is equal to 1 upon 2 pi. Now you can substitute the values u and v. So keep u as it is, that is minus pi minus x, keep as it is. Okay. So v1 minus cos nx upon n minus u dash minus 1. v2 is minus sin nx upon n square. Further, if you simplify, u double dash is 0, so leave it. Therefore, this is from 0 to 2 pi. Okay, now you can simplify this, students. This is equal to 1 upon 2 pi is there. Okay, now further, if you simplify this value, students, you can see, please remember this once again, that is sine 2n pi is equal to 0, or if you put sine 0, it is also 0. Means if you put 2 pi in this sine, this is 0. Even if you put 0, it is also 0. Means it remains only this value. Substitute 2 pi and 0. Okay, substitute one by one. So this is equal to, this is pi minus 2 pi. First I will substitute 2 pi, and this is minus cos n 2 pi upon n. Okay, and then we have this as minus pi minus 0, and this is minus cos n into 0 divided by n. So this is what we have simplified this value, students. Okay, now further, if you simplify the value, so please remember again the functions that we have going to take here. It is cos 2n pi is equal to 1, or if you substitute 0, cos 0 is also 1. Fine. Now I will simplify this value, students. Yes. So this is equal to, keep 1 upon 2 pi as it is. Yes. So if you take pi minus 2 pi is minus pi, I'm going to take here, and minus cos n 2 pi is 1, therefore minus 1 upon n remains. See, just please check once again. Minus 1 upon n is going to remain. Further, if you simplify, yeah, I'm going to get here pi. Okay, here also you can just simplify here. So the value I'm going to get here minus 1 upon n. So because cos 0 will be 1. So further, if you simplify, this will be equal to 1 upon 2 pi as it is. So minus into minus will become plus, that is pi by n. Minus into minus plus pi by n, which is equal to, it is 2 pi by 2 pi n. Means pi by 2 pi by 2 will get cancelled. I'm going to get this as 1 upon n, students. So you have calculated bn. So therefore bn is equal to 1 upon n, students. So it is very simple. So a naught 0, an 0, bn is 1 upon n. So substitute in the formula. Therefore from the Fourier series, f of x is equal to 0 plus 0, which is plus summation n 1 to infinity. We get this as 1 upon n sine nx, sine nx. So we'll keep this equation 1, students. Okay, now further you want to deduce this value to Yes, it is pi by 4. We can take directly x value. X value I'm going to take this as pi by 2. So put x is equal to pi by 2 here friends in this equation. Therefore, f of pi by 2 you are going to calculate, which is equal to summation n 1 to infinity 1 upon n sine n pi by 2. Yes, I'm going to get here sine n pi by 2 students. Okay. So next you can see what is the value given. F of x, you first see what is given. F of x. F of x, I am going to substitute here this side. So here I will substitute f of pi upon 2. So f of x you should know first. F of x is equal to pi minus x upon 2. Therefore this is pi minus pi upon 2 upon 2. So if you simplify this will be pi upon 2 which is equal to pi by 4. So therefore I'm going to take this as pi by 4 which is equal to, I can see this is n pi by 2. Okay, means this is an odd function. If you substitute the values you are going to get even as 0. Please remember this. Yes, so means if you substitute n is equal to 2, if you substitute you are going to get this as sine pi. So what is the sine pi? If you can just calculate, yes, you can see here you are going to get 0. Sorry, if you substitute n is equal to 1, n is equal to 1, if you substitute sine pi by 2 you are going to get first value. We'll substitute 1 only. Okay, we'll substitute 1 by 1. So if you substitute 1, what values you are going to get students? Yes, 1 will be 1, sine pi by 2 is 1. Okay, then next I'm going to get this as minus, if you put n is equal to 2, yes, n is equal to 2, so it is sine pi is 0, leave that value, go for n is equal to 3. So if you put n is equal to 3, sine value will become 1 and n is 3. Further if you simplify for 4 it is 0. Then if you put 5, sine 5 pi by 2 will become 1. Therefore this will be 1 upon 5 and so on. Therefore we have deduced the value pi by 4 is equal to 1 minus 1 upon 3 plus 1 upon 5 minus 1 upon 7, so on. So this is what we have calculated example number 3. Is it clear students? So have you understood everything? Yes. Now please try for the next example number 4. So very simple students, you can just take any interval and calculate. First obtain the Fourier series. Yes, please try yourself students to represent f of x. So they have taken here f of x is equal to x minus x square in minus 1 to x to 1. You can take now interval minus 1 and 1 is there here students. Now I will simplify this solution. So length you are going to take this as 2l. Length will be equal to, and I can take here how many values are there students? 2 values are there. Therefore you are going to get this value as, yes, right now. Okay, so 2l is equal to, you can see the length LHS will be 1, RHS will be 1. So 1 plus 1 will be 2 students. So I'm going to take 2l is equal to 2, that implies l is equal to 1. So this will be very simple. So you can take the function now, f of x. F of x is equal to a naught upon 2 plus summation n 1 to infinity an cos n pi x upon L is 1, okay, plus or C is 1, what we have taken already. C or L is the length same, so please remember this. Bn sine again n by x upon L or C. C is the length interval they have given it here 1, so I'm going to take 1 only. So here it will be n by x. So if we substitute a naught, a n, b n, you'll get the answer. Okay, students, one by one we'll try now. I'm going to find a naught first. So here again, c we have taken 1. So please remember integration will be from -1 to 1 f of x dx. Is it clear? Okay, substitute the values friends here one by one. Yes. So a naught function, I think f of x they have given x minus x square. Okay, no problem. Substitute the values friends. X minus x square. So this is dx. So now we substitute f of x value. So this is equal to 1. I am going to take constant, leave it integration -1 to 1 x minus x square dx. Okay, this is very simple, students. You can see integration of x is, yes, it is x square upon 2 minus integration of x square is x cube upon 3. Upper limit and lower limit 1 and -1. Okay, first you substitute 1 and then you substitute -1. Put it in the calculator and tell me the answer, friends. You are going to get this as -2 upon 3. So a naught you have calculated very easily. Yes, as I have told you. Next you can find an. What is the formula for an, students? Yes, 1 upon 1. Again, c is 1. So I have taken L. Integration will be from -1 to 1. F of x. Please try yourself, students. N pi x upon L. L is 1 or C is 1. So this is equal to, substitute the value of f of x, that is x minus x square cos n pi x dx. Okay, so now we can see again we have to calculate for integration of u into v. Okay, so please calculate the integration. Yes, I will take here the integration. So that is, yes, it is okay. So what is integration of u into v, students? Yes, integration of u into v is u v1 is right. It is u v1 minus u dash v2 plus u double dash v3. Okay, now you are familiar now. X is, u is nothing but x minus x square. U dash will be 1 minus 2x. U double dash will be -2. U triple dash will be 0. Means all the terms after triple dash differentiation 3 times it become 0. Okay, now go for v is equal to cos n pi. So please remember we have taken n pi x, sorry, x. Okay, v1 I am going to calculate this now. Yes, it is sine n pi x upon constant term is n pi. So please remember here n pi is a constant. So v2 again integrate this, cos n pi x will become minus cos n pi x. N pi is already there, multiply again n pi. So this will be n square pi square. Okay, further if we continue, v3 will be equal to, yes, further if we calculate v3 minus keep as it is cos n pi x. Integration will become sine n pi x. Already n square pi square is there, so this will be n cube pi cube. So now just substitute in the equation, friends. So this is equal to integration minus 1 to 1. So sorry, I'm going to substitute the integration. So no need of writing integration once again. This is u dash. U I'm going to keep as it is, that is x minus x square as it is. Then v1. V1 is sine n pi x upon n pi. Okay, minus u dash. U dash is 1 minus 2x v2. V2 we have calculated this as minus cos n pi x upon n square pi square. Please continue here this side, plus u double dash is minus 2, and last one is v3. Yes, it is minus sine n pi x upon n cube, and this is pi cube in the interval minus 1 to 1. So when you take x as 1 to minus 1, please remember here you can see this sine n pi x. When x is equal to 1, when x is equal to 1, you can see sine n pi will be equal to 0. Similarly, if you put x is equal to minus 1 also, you can see this is equal to sine minus n pi is also 0. Means if you put here 1 and minus 1, this will be 0. Put here 1 and minus 1, this will be 0. What is remaining? Only this term is remaining. We are going to substitute 1 and minus 1. Okay, let's simplify this. Okay, this is equal to minus. I will take outside, students. Okay, there will be no confusion. So whatever terms are common, I am going to take here outside. That is minus 1 upon n square pi is constant. I will take it outside. What you are going to substitute? 1 minus 2x I have to substitute here, and this is minus cos n pi x upon n square pi square. I have to substitute here the values as minus 1 to 1. Okay, we will substitute one by one. First I will substitute one value. Okay, I will keep this minus as it is, minus 1 upon n square pi square as it is, students. So this will become 1 minus 2. Okay, this will be 1 minus cos, yes, n pi. X is 1, n square pi square is outside. No need of writing again n square pi square again and again. They have removed it outside only, friends. Don't worry. So this n square is not there and pi square is not there. Okay, so this much is remaining. You can simplify this, students, very easy. You have come to finish the example very easily. So you can see, yes. So this is remaining. So first I have substituted 1. Next I will substitute. It is minus 1. So this will be minus 1. 1 minus into minus. This is okay. Minus I will put 2. Okay, fine. So this I will keep this minus outside only. So this will be again minus cos minus 1. Okay, students, don't get confused. So this is equal to minus 1 upon n square pi square. You can see 1 minus 2 will become minus 1. Minus into minus will become plus. 1 into cos n pi. Okay, here also you can see minus. Here we have, I'll keep minus here only. Minus into minus plus, this is 3. and then you can see minus is there, minus into minus, I will make this as plus. Please remember, minus into minus plus, I have taken this as plus, and this is again cos n pi minus 1 is again cos n pi. You can simplify yourself, students. This is equal to, you can see 3 plus 1 will become 4, so therefore I am going to take minus 4 cos n pi. N pi is constant, cos n pi is constant. N pi is common, so I have taken outside. So please remember the formula for cos n pi, students, which is equal to minus 1 raised to n. Now you are perfect with this. Now I can get this is equal to minus 4 minus 1 raised to n upon n square pi square. So this is what we have calculated for a n. So this is our a n. So a naught you have calculated, a n you have calculated, students. Okay, now what is remaining, students? Bn. Okay, substitute now Bn. Bn, I think you have come across the formula. So we'll write Bn this side. So Bn, please try yourself, students. Try yourself. Bn is equal to, yes, 1 upon again our c, that is it is equal to 1, integration from minus 1 to 1 f of x sine n x dx. So again n pi x upon c is 1. Okay, no problem. Let's simplify now further. This is equal to integration minus 1 to 1. Please remember what is f of x. It is x minus x square. This is sine n pi x dx. Okay, so what I will do, I will continue this here. So bn is equal to, so bn, I'm going to take this as bn is equal to, I will get this as integration minus 1 to 1 x minus x square. Okay, sine n pi x dx. Okay, students, again simplify as it is, integration u into v, students. This is u and this is v. So you can see integration of u into v, u v1 minus u dash v2 plus u double dash v3 and so on. You take this as x minus x square, and v you have to take here sine n pi x. Okay, now simplify. U dash 1 minus 2x, u double dash minus 2, u triple dash is 0. Similarly, v1 will be equal to, yes, sine will be now minus cos n pi x upon n pi. Again integrate same, v2 will become here now, yes, it is minus sine n pi x upon n square pi square. v3 will be equal to, yes, minus into minus will become plus, so therefore cos n pi x upon n cube, and this is pi cube. Substitute the value, students, here, u into v integration, which is equal to, you are going to get this value as, this is equal to, yes, first keep u as it is. Okay, sine n pi x, sine n pi x integration, you will get this as minus cos n pi x upon n pi. Okay, then minus u dash 1 minus 2x v2 minus sine n pi x upon n square pi square, then plus u double dash minus 2 v3 cos n pi x upon n cube pi cube. So this we complete because u triple dash will come, which is 0. After that, everything, all the values will be 0, students. Please remember, here we can see here, students, this we are going to take the values like this now. We're going to take the value, yes. I can see if you take sine n pi, which is equal to 0, if you take x is equal to 1 or x is equal to minus 1, means if substitute here 1 or minus 1, this sign will be always 0. Please see, the sign will be always 0, students. Okay, now further we will go to simplify this. Okay, this is equal to, now substitute the value, that is 1. So wherever x is there, if you put 1, yes, you can see 1 minus 1 will be 0. So this value I'm going to get this as 0. Next, I will put 1 in this value, that will be plus minus 2 will remain as it is. This will be cos n pi upon n cube pi cube as it is. Similarly, I will put now minus 1. So minus 1 if I put, this will be minus, okay. So this will be minus 1 minus 1, because minus 1 square will be again plus 1, therefore minus 1 minus 1 I'm going to get here. Next, substitute again, next minus cos n pi upon n pi, x is minus 1, again cos minus n pi x is again cos n pi x plus cos n pi x, therefore I will keep this as it is. Next, plus minus 2, this will be cos, yes it is, n pi upon n cube pi cube, student. So this is how you have to simplify 1 to minus 1. Okay, now simplify this, students. Yes, you can see if you simplify this, this is equal to, what is common here, students? It is n pi is common in this, n cube pi cube is come. I will remove n cube pi cube is there. I'll just simplify this. This will be minus 2 cos n pi. If you further simplify, you can see minus 1 become minus 2. This is minus 2. This is minus 1 is there here. So minus into minus plus. Plus into minus, it will be minus 2 cos n pi upon n pi. Here we can see here, students, it is again minus 2 cos n pi upon n cube pi cube. Yes, please check once again. Substitute the values. 1 1 minus 1 0, this is 1. So when you put minus 1, yes students, please check. Yes, you can see here Minus into minus, it is plus. So this value and this value will get cancelled. Therefore, you get the answer as Bn is equal to minus 2 upon n pi. You can see, you remember the formula, that is cos n pi is equal to minus 1 raised to n. I'm going to write this as minus 1 raised to n, or you can take like this, minus 2 minus 1 raised to n. I can write like this, it is plus 2 minus 1 raised to 1 minus 1 raised to n, or I can write this as 2 minus 1 raised to n plus 1. Yes, therefore I will write this formula as Bn is equal to 2 minus 1 raised to n plus 1 upon n pi. Therefore, substitute in the formula, f of x is equal to minus 1 upon 3, yes friends, minus 4 upon pi square summation minus 1 raised to n. Just substitute a naught, an and bn. You are going to get this answer. Just I am substituting a naught, an and bn, friends. So this is your answer. So please try yourself, friends. Yes, if you have any doubt, please ask me. Yes, thank you.